I'm Sarah Ray. I'm the editor at SmartCitiesWorld, and welcome to today's webinar on the importance of openness and interoperability in smart cities. Today's session, we're going to have two short presentations and then a question and answer session where you'll have the chance to get your questions answered by today's experts. So we encourage you to send your questions in. You can do that via the control panel on your screen where you'll see a chat box. Just write your question in that box and press send, and we'll aim to answer as many questions as we can today. And any that we don't get to, our panelists can follow up with you after the event. Today's session is being recorded, and after the webinar finishes, we'll be sending out an email with a link so that you can watch it again whenever is convenient for you. Today's webinar is in partnership with Paradox Engineering, a company which specializes in IoT solutions for urban environments. And at SmartCitiesWorld, we recently produced a report with Paradox Engineering, and that's available in the resources area of your console. In researching that report, we found that many cities are at a pivotal point in their digital transformation, and they're at a point where they've got to make decisions about which technology to use and which vendors to work with. And the route that they take and the decisions that they make there could have serious implications in terms of what they can achieve further down the line. So with that in mind, in today's webinar, we're going to look at the importance of openness and interoperability and some of the practicalities of making those decisions and making that happen in cities. So today's experts, I'm going to be joined by Gianni Minetti, who's the President and CEO of Paradox Engineering, and he's going to make the case for why openness and interoperability are so important in the smart city context. And we're also pleased to have Bruno Opazzo Rui, who is the Director of the Enabling Infrastructures for Smart Cities program at the Chilean Economic Development Agency, CORFO. And Bruno is going to share some insights into how Chile is driving such an open and interoperable smart city approach, and give some of his takeaways from what's been achieved in those cities so far and a view to what's coming next. So with that in mind, I'm going to hand over to Gianni, who's going to set the scene for us. Thank you and welcome, Gianni.
Thank you, Sarah, for the kind introduction. And thank you, Sarah, for already mentioned who I am. So, Gianni Minetti, CEO of Paradox Engineering. And today we are going to basically go through a path, okay, a journey, okay, through a few slides, okay, on how interoperability is important for a smart city and is important, okay, for any IoT business development area, which smart city is just a sub area, okay. Yes, I'm the CEO of Paradox Engineering, and I'm also the founder of Paradox Engineering. I'm saying that because concept of openness and interoperability are always been with us and with me, okay, since the inception of the company, okay. So I'm just mentioning this aspect, okay, for this reason. So let's start with a very nice question, okay, kind of a joke, okay. It's a so-called pleonastic question, okay, where the answer is already in the question. Would you buy a laptop or a smartphone, or would you ever buy a laptop or smartphone which can only connect to a proprietary network? Today we all buy, okay, devices that connect to network, okay, and we don't even think, okay, if we want to connect to network A, B, or C, or vendor A, B, or C, okay. We just take for granted, okay, that we connect to the Wi-Fi, we connect to our office, we connect to the public internet, okay, and what we take for granted is just one word, is interoperability. Now, okay, just to set the basis, okay, and some mindset, okay, to go through the next slides. Here is how we explain, okay, what is Internet of Things, okay. Internet of Things is the word of the moment, okay, is the buzzword of the moment, but from our point of view and our perspective, okay, Internet of Things existed since a long time, okay. So you see at the bottom left of this slide, okay, the device, okay, called mainframe. I'm not old enough, okay, to have seen that age. We are talking about the mid-60s and the 70s, the 60s and the 70s. The mainframe, okay, were the devices, okay, and that were producing and consuming data. Then the industry at that time realized that interconnecting those devices that were producing and consuming data would create additional value, and actually moving, okay, from processing of data to creation of shared information and shared actionable information. And so we saw the first network of mainframe connected with very specific and ad hoc telecommunication solutions. Of course, okay, the people, the entities that could afford the mainframe by then were governmental body or very large corporations. And here we are in the 60s and the 70s or mid 70s, and then we saw by effect, okay, of scaling the electronics, okay, we saw a new name coming up in the industry: workstation computers, or workstation where something more affordable, okay, although, okay, company, okay, approaching the decision, okay, do we want to buy a workstation or not, was an investment decision. Okay? And these were, again, okay, the next generation of device machines, okay, producing and consuming data. Again, okay, at that age, and here we are in the late 70s, mid 80s, the industry came up with realizing that interconnecting these devices and machines among themselves was producing additional value. And so again, the network of workstation came up. Okay? And here we started to see some names on the network, like, I don't know, we all remember about network like Token Ring from IBM, okay, DEC network, okay, from Digital, and so on and so forth. Good, okay, and good answer, okay, to the needs of the economy. Those networks were kind of proprietary, okay, and conceived, okay, by specific industry, okay, with okay. And then we move, okay, from the workstation, okay, to the next level of devices consuming data, the personal machine, so the personal computer. And here we are really at the late 80s and the early 90s, and something happened, okay, here. It was the advent of the internet, okay, the release by DARPA of the specification, the standard, and the code, okay, for the internet, okay. And from there, okay, the whole industry, okay, whoever wanted or was interested could take that specification, that open standard, and implement whatever device, okay, and connect to a network, okay. And that's why, okay, we stopped to ask, okay, which phone we want to buy and which device we want to buy based on which network we want to connect. The network was the internet. So reducing our scales, laptops, okay, and portable devices. Again, today we are in the Internet of Things, okay, because we realize that the entity producing and consuming data are on different scale, and they are what? Okay, they are our refrigerator, microwave, appliances, okay, street lights, waste dustbin, okay, parking lots, and so on and so forth. So the paradigm is not going to change, okay? We need one network, okay? We need the ability to interconnect whatever device, okay, we want to interconnect, or whatever device creative industry, okay, believe that can connect to generate value, okay, and without making, I would say, drastic choice, okay, we want to use network A, network B, and network C, and which is going to be the winner in the future. Okay? This is the essence of interoperability that brought us to the age we are today. Okay, then if we take a different perspective, okay, and we look at the city. City has, among the various services rendered to the citizen, we have the street lights for public lighting, we have mobility and traffic for parking, mobility, we have energy, water, supply, we have waste management, and so on and so forth. Okay? Would you imagine, okay, a city where every urban service, okay, that I named a few of them, is managed through a separate siloed network and solution? That would be a nightmare, okay, but unfortunately that is what is still happening, okay, today, or not happening at all, okay, because there is no maturity today. Let's say we want one network to manage all the application and want to cross the silos, but under the hypothesis, okay, that each one of these city service, okay, is managed with a solid solution, okay, we get higher fragmentation, we get very high complexity in managing different technology with different vendors, with different skills, very high cost because all the costs are duplicated among the various services, and therefore less efficiency, less sustainability, less economical sustainability, and less readiness for the future. Okay, if one solution is proprietary, based on proprietary technology, there is no way you can extend, okay, for the application that you don't see today, but tomorrow, okay, may be there. And this is not the way, okay, to support, okay, the three pillars of a city. A city should support and enforce livability. So services should be rendered, okay, at appropriate quantity and quality to the citizen. Should be sustainable, and also the investment should be sustainable for the city. And whatever infrastructure investment is done should also be along the fostering the local economy. So translating this to the IoT paradigm, okay, I mentioned before, fostering local economy means, okay, anyone should be able, okay, given, okay, the credential to access the infrastructure, okay, to build an application, to build a device, connect to the network, and generate their own business. Okay, this is the very well-known, for example, app model, okay, or even web model, okay, in the 90s. Livability means that in order to provide good services, okay, at appropriate quantity and quality, as Newton said, okay, there is nothing that you can improve if before you cannot measure it, okay? And so we need to measure waste, parking, lighting, and so on and so forth to control and improve it, okay? And sustainability, okay, it's taxpayer money, okay, that goes in those infrastructure, okay, so there is really no point, okay, in duplicating investment or limiting the number of investment you can do, because you spend everything on one proprietary technology, and then you can only serve one application, okay? And this is the economical sustainability. So, how you start a smart city, okay, interoperable? Well, usually you start with the very first and compelling application and service. So whatever it is, okay, parking, lighting, waste, metering, and you implement through that an open and interoperable smart urban infrastructure. And then, okay, you keep adding, okay, the other services that the city needs, okay, and integrating the same infrastructure rather than duplicating the same infrastructure. And then you keep growing, okay, prepare to design to the next smart one. And the next smart one may, I bet, okay, I'm 100% sure that is not in this icon you see here, okay. The next smart one is something that we don't see today, but we can be reasonably sure, okay, that it's going to be there tomorrow, okay, just by, for example, correlation of data and correlation of devices. And all this, okay, is going to be enabled only by and through interoperability. So what is interoperability, okay? By definition, okay, is the ability of systems to share data and turn information into action. As I mentioned before, mainframe, workstation, personal computer, okay, they were growing in their interoperability level, okay, starting with no interoperability, or at least interoperability based on single and proprietary technology, and by exchanging data, and they were turning this data into actionable information. And the second sentence here, okay, is without any access, implementation, or usage constraint. This means that specs should be there, specs should be freely available, specs should be understandable, easy interpretable, okay, it should be implementable, okay, without reducing and minimizing, removing at all, okay, any level of interpretation about the specs, okay, and even providing, okay, source code or schematics, so third parties, okay, can take the translation of this specification of interoperability, use that code, okay, and build their own devices, because the value would not be, okay, in the developing the interoperability, will be developing on top of the interoperability. Okay? And then more specifically, okay, when we come to smart city, we have three levels of interoperability. One is interoperability here on the right at network level. So it's the internet as we know it today, IP protocol. For us, okay, we believe that the IP version 6 protocol is going to be the cornerstone of interoperability into smart city. Device interoperability, okay, means that device should be able to talk among themselves. Okay, we should not think in a hub-spoke infrastructure for city where everything has to go back to the central, okay, and then go down to the device. So interoperability among devices, and of course interoperability at platform level. Okay, the software, okay, suite, okay, that manage the network and the device and the data, okay, should be equipped, okay, with a rich, comprehensive, and complete set of API and SDK and source code. Okay, so third party can take start and using them and building their added value on top of it. And then, okay, it's more academic, or there is semantics, interoperability. An example, okay, why, I don't know, street light, the lighting, the public lighting department should talk, okay, with the waste management department, okay, this is semantics. I would say also political interoperability, okay. And then there is the syntax, okay, it's language, okay. So our vision at Paradox Engineering for interoperability. So openness and transparency to generate trust. Okay, if you're open and transparent, okay, and you generate trust, and if you generate trust, okay, you can have very open dialogue, okay, with whatever stakeholders are around the project, okay, and then focus the energies on making and creating project and building the future and addressing the needs. And open standards, okay, interoperability foster, okay, the transformation of cities into smart cities, okay, because there will be no fear to deliver the first application, okay, and then knowing, okay, that the investment on that first application will basically represent the foundation of any other future application for the city, okay, and moving from one application to an X application and turn the city real smart, okay. And application agnosticism, so sorry for misspelling this, to support any urban service with one wireless network, okay? And that's it. Why open standard and open data model for smart city? Again, okay, and kind of seems I'm repeating myself, but I want just to re-emphasize this, is to remove concern linked to supplier, okay? No one wants to be handcuffed by supplier, okay? And no one wants to be caught, okay, by promises, okay, of suppliers or whatever, say we are interoperable or we are going to be interoperable in the future, okay. Interoperability is something they're achievable today, okay, available in nature between companies. Okay. Then, okay, open standard to concentrate on the city and the citizen actual needs, providing them higher quality of life. So I was saying livability before, and sustainability, and also boosting the economy, okay, as I said before, fostering the local economy. This is only go to interoperability. To ensure that any choice of today does not hinder future one. Said in other words, okay, removing the risk of doing the wrong investment, okay, and being blocked, okay, by the investment because there is no way to further on that investment in technology. Okay? And therefore, okay, increase the trust in technology and its adoption. We at Paradox Engineering, we do something similar, okay? As I said, okay, for us, openness, interoperability, and open source and so on and so forth has been in our mind, okay, since the inception of the company. And we have an open smart urban network that delivers several, I would say, few applications that are in demand of cities or are in demand of smart cities. Today, we do smart lighting, we do smart parking, we have environmental sensors. Okay, we have one network, open interoperable, mesh network, wireless, IPv6, and we have one central application for managing device and data. All those elements, as I mentioned you, the devices, okay, for the three vertical applications that we have today, the network and the software platform, the CMS, they all provide full interoperability by documentation, by API, by source code. Okay? Why only 3 applications? Okay, well, maybe tomorrow going to be 4 applications, maybe 5. Okay, but we are not going to be the one with such a fantasy, okay, to deliver the hundreds or the thousands of applications that a smart city may need. Okay, and this is why we need interoperability to foster local economy, because we believe, okay, I trust that there are people with a lot much more creativity than we have, okay, and they will find, okay, what to do, okay, with the data and with the network when this is open, okay. This has been said many times, okay, and you may have heard many times, but if you want to plan for the future, want to have a look at the future, look at the past, okay, look what happened in the internet through the interoperability. We should aim to have the same into smart city through interoperability. Well, already mentioned, okay, a single interoperable future-proof platform to manage wireless IoT, wireless speed IoT, parking, lighting, waste, okay. And this is the last slide, okay. How do we grant interoperability, okay, and how do we grant interoperability beyond our words of Paradox Engineering, okay. We found, okay, that being a part of UCFI Alliance, is one of the answers. But before talking about that, okay, as said, envisioned since very inception of paradox engineering, smart urban network, interoperability, open standards. Okay. We have an open roadmap, okay, of keeping openness with third-party IoT device to communicate, and we are again interoperable at all levels. Okay, network, gateways, software, okay, and providing software development kits, okay, and providing hardware development kits, and combination of this, and then in open source, okay, for the community to take. Community, which is community. The community is UC5, just mentioned before, and the goal of UC5 is a non-profit alliance, okay, that has been created, okay, with the purpose of sustaining, promoting interoperability at data model level and network level for smart city. And we are honored and glad, okay, to be a strong sponsor of UC5, and actually an active sponsor of UC5, okay, and working on technical and marketing work. Well, last, okay, just because I didn't want this to be a marketing pitch, we are Paradox Engineering. We are almost 60 people. We are based in the southern part of Switzerland, and I would say almost 50 of these people, 60 people, are engineers developing hardware, software, and solutions. Okay. We are part of Minebea Mitsumi Group since 2005, and Minebea Mitsumi Group is a large Japanese corporation, top 10 listed in Nikkei, and we represent the edge, okay, of their strategy in IoT and smart city. So combination of these two things, you see the two flags, okay, I would say Swiss precision, Italian creativity, okay, because many of us are Italian, okay, with Japanese trustness, okay, and robustness. And I think I'm done with my presentation, Sarah.
Thank you very much, Gianni. That was really useful. And just to remind everyone that you can send in your questions, we'll be taking them after the next presentation. So please send them in via your panel. And yeah, we're looking forward to receiving those. And with that, I'm going to hand over to this one. I'm going to hand over to Bruno Opazzo Rui from the Chilean Economic Development Agency, CORFO, to share his insights from some of the work that he's doing with them in Chile. Thank you, Bruno. Welcome.
Hi, Sarah. Thank you so much for the presentation. Okay. Okay, good morning in Chile, good afternoon in Europe. My name is Bruno Passo, Director of the Program Enabling Infrastructure of Smart Cities of CORFO. The objective of this initiative is to promote the enabling conditions which allow the massification of digital solutions for open smart cities, in coordination with municipalities, and making easy new entrepreneurship, the development of a technological ecosystem, and promoting the innovation for a better city. Since year 2017, we have worked to generate the foundation for the deploy of multi-service enabling wireless sensor network using the street light as a backbone to develop a smart application. This IoT network type are based in open standards that enable system operability. Okay, and what is CORFO? CORFO is the Chilean Economic Development Agency that works daily to improve competitiveness and the productivity diversification of the country by encouraging investment, innovation, and entrepreneurship. Smart City. Today we talk about Open Smart City. Open Smart City may be defined like a resilient, inclusive, and collaborative built city that uses technology and data to better the quality of life for all people. At the present, the most innovative cities in the world has adopted the Open Smart City concept associations such as Future Cities Canada, Open North Canada, and Open and Agile Smart Cities has been created. Okay. Open Smart City can be understood in terms of open data, open standard, open source information, open governance, and open collaboration to enable building new or modify existing services for residents in any scale. Okay, our program has the following specific objectives. 1. Develop governance to coordinate adoption of intelligent systems, financial models, technological capabilities, promotion, and integrate management centers. 2. Deploy enabling conditions to massify open and city solutions, like wireless sensor network, open standard in public procurement, interoperability smart city systems. And the last, empower an ecosystem and encourage entrepreneurship to develop an open smart city in Chile. The base of any smart city, such as define the Inter-American Development Bank, are 1. Connectivity infrastructure, which include public, private, broadband, and narrowband network. 2. Sensor and connected device, which capture data and send it to management center for processing. 3. Integrated operation and control centers equipped with servers and systems that process and analyze the data of the device and distribute information to other institutions or other providers. And 4. Communication interface to send and receive information related to open data and open or e-government platform. We need the network to support sensor. Solution based on wireless network can be more competitive than option wire. Municipalities could be guaranteed the existence of wireless data communication, open and multi-service for IoT sensorization. The strategic intervention of the Smart City Enabled Infrastructure Program consists in 1. Living labs. We design, we implement for IoT wireless sensor network and smart city solution testing like smart street lighting, smart parking, and environment sensors. Our action plan is develop a technical collaboration with municipality, diffusion of methodology to lay the foundations for technological implementation and subsequent scaling in metropolitan areas in Chile. And the last point is the promotion of creation and development of integrated management center to coordinate and govern a smart city project, unify and process information source and open data, ensure interoperability, continuous improvement, cybersecurity, and create critical mass for ecosystem and big data development. The main pillars of our program are 1. Sustainability, enables conditions, and good practice. The first activity we have to do was create a panel of experts with universities, with areas in the government, and analyze connectivity options for IoT in high and low frequency, which we classify into 4 groups. 1, LP1, cellular, personal area network and wireless LAN network, and neighborhood area network and field area network. In the case of FP1, we found the following aspect to take in account. Need have an operator. FP1s require a line of sight between gateway and sensor. Due to their star topology, that can operate well in the open field, but not in areas with high density of building, like the city of Santiago de Chile. In star topology, it's required to place a gateway to 50 or more meters height using buildings or antennas tower in addition. In Santiago de Chile, there are some LP1 proof of concept has been carried out, but there are no massive deployments such as street light network. In the case of cellular, 3G and 4G are available today, but it requires hiring a data plan and SIM card for each network device. Also, the high power consumption make difficult in public space. In addition, still there are areas where cellular coverage cannot be assured today. The new option for connectivity for sensorization that include in 5G, like LTE M1 and MB IoT, are not commercially available. In Chile, only a few MB IoT proof of concept have been performed. The cellular operators are thinking in offer an end-to-end closed service that includes sensors, connectivity system, and the data processing. In the case of personal area network and wireless LAN network, these technologies were developed for local area, home network, and home automation, with a range of tens of meters and limited number of devices. This network uses the 2.4 gigas band that is saturated by Bluetooth and Wi-Fi several years ago, which generate less coverage due to interference. And in the case of field area network and neighborhood area network, in this type of network and for IoT smart city network deployment, the standardization institutions such as IEEE and IETF that have governed the development of the internet more than 30 years ago have generated new open standards. In 2012, the IEEE was approved the standard 802.15.4G, also known as the Smart Utility Network. This protocol scaled to thousands of sensors with coverage of several kilometers in mesh topology, use sub-1 giga bands for better propagation. The Internet Engineering Task Force in 2015 published the 6LoWPAN protocol that mentioned Yanni, is IPv6 over LoWPAN, over low power area network. In this way, it's possible to provide IPv6 connectivity on device with constrained capacity. The Internet Engineering Task Force also developed protocols such as CoAP, Constrained Application Protocol, similar to HTTP, but for low power device. The Zigbee Alliance in 2016 published the Jupyter Mesh Network for robust and scaled smart city solution based on open standards such as IEEE 802.15.4G and 6LoWPAN without using more the Zigbee protocol. Okay. The program deploy proposals are the following to municipality. First, smart street lighting. The first smart project municipal with luminaires with the standard socket ANSI 7 pin. Public luminaires is the backbone for deploy a multi-purpose and ubiquitous narrowband 6LoWPAN network. and include out-the-box lighting remote management. Okay. Oh. Okay. It's the network is very slow in this moment. Okay. In this slide, we present an IoT network architecture proposal for an open smart city, where intelligent public lighting is the base infrastructure for the implementation of IoT ecosystem. The luminaires become router nodes of the IoT internet infrastructure. A mixed topology is proposed, mesh between luminaires and a star between the luminaires and the final device, or low capacity sensors close to them, such as parking sensor. The integrated operation and control center is connected to the city in real time via internet and different communication network with thousands of sensors and digital devices disseminated by the urban network, like video cameras and other information generating equipment. The data are processed in an integrated operation and control center, a layer
I think we lost your audio there, Bruno. Are you still there? While we wait for Bruno to come back, perhaps we could take a quick question with you, Gianni, that's come in, if you're there. Gianni?
I'm here.
Hi. Let's take a quick question while Bruno figures out his connection. So thank you for your presentation earlier, but one of the things I was wanting to ask you is, in your experience, how widely do you think that cities are convinced of...
Okay.
Oh, okay, we'll come back to that question, Gianni, and Bruno can continue.
Okay, thank you.
No worries.
Okay. In these two following sheet, we present one of living labs that we have developed in the downtown of Santiago de Chile. We have implemented the first 6LoWPAN network in Chile. It's considered 2 gateways, 100 intelligent luminaires connected in a mesh network, and 84 parking occupancy sensors. In addition to a central management system or CMS and an app mobile for fine parking. In this way, we have been able to validate open standard. We have executed more than 5 updates of the firmware of each device in over-the-air manner. As technology has improved, a new protocol has been incorporated at the application layer, such as COAP, MQTT, and lightweight machine-to-machine for device management. Finally, the first municipality in Chile to adopt the open enabling infrastructure is the municipality of Las Condes. This municipality is completing the deployment of an IoT 6LoWPAN network with 23,000 public luminaires that creating a network that will provide IoT connectivity to the entire community in this area. Today in Santiago, there are 100,000 streetlight IoT ready with 7 pins NC socket. Okay, the next step in the development of the Open Smart City program as the following: expand collaboration with municipalities and the regional government, diffusion of a study model master of plan for the deployment of an Open Smart City enabled network, escalation the project to the 8 areas, metropolitan areas of the country, support development of technological ecosystem, promotion of the human capital, generation of new companies, and entrepreneurship competition.
Thank you very much.
Thank you so much. Sorry for the slow.
No problem at all, and thanks for getting back with us and for sharing those examples from Chile. So we're going to take some questions now, and Gianni, I'll come back to you to the question that we were just discussing before. And I was hoping to get your take on, so you set out the case for interoperable and open smart cities, and wondered, in your experience, how widely you think cities are already convinced of and taking that approach.
From our experience and what we measure, okay, while going out, okay, on the streets, okay, it is what the city are expecting and need, okay, in order to seriously undertake the project, okay, of connecting devices, okay, and creating the first step of a smart city, okay. So being reassured by design. And as I mentioned before, what is interoperability by design, that the investment that they're going through, okay, is going to support interoperability. So it's a growing and high demand, okay, by city on that.
But with that in mind, then, what do you think are the challenges to achieving it that cities still face?
The challenges to achieve. So can you repeat the question, please?
The challenges to achieving this open interoperable vision which you outlined.
Well, the challenges would be to create, I would say, a movement, okay, that basically, rather than pushing, okay, is attracting, okay, the various stakeholders and actors on that. And to create a movement, okay, you have to understand, okay, which are all the interests and the needs, okay, of the stakeholders that rotates around an open interoperable city, okay, address them and work peer-to-peer with them, hand-to-hand, okay, to achieve, okay, that openness and interoperability for smart city, and having them to grow it as a community.
Yeah. Okay. Bruno, would you have anything to add to that about the challenges in achieving this open and interoperable approach, and any progress that you're seeing in particular?
Okay, the main achievement of our program in Chile was introduce the municipalities in the concept of open smart city and the need of deploy enabling infrastructure for making easy entrepreneurship, adoption of digital solution in open smart city. And other thing is established as a standard for public luminaires in Chile, the 7-pin ANSI socket. This matter, provider of luminaires, put luminaires, and companies is specialized in IoT network. It's possible to put on the socket an outdoor lighting controller, and this manner use the infrastructure of a street light and put a wireless sensor network with in the all of the city. As a difficult, we can point out the pressure of luminaire suppliers with proprietary telemanagement solution. This is a very big difficulty.
Could you expand on that a little bit?
Okay.
Could you expand on your last point a bit about the challenge?
Okay. Like tell Gianni, in this system, in this new IoT network, interoperability is the key. Interoperability has two layers. One, interoperability between the central management system with other applications, like a GIS, like a urban control, like integrated operation management. And the network must be open to other sensor for other companies.
Yep.
And today, companies to provide luminaires only offer proprietary telemanagement solution, but that no offer a multi-service network, an open network based on open standard. This is the question. This is the problem.
Yes. Okay. Thank you. So, Gianni, to go back to you, you mentioned about where cities can start to build out that open and interoperable approach by starting with one solution and then building from there. How do you, cities have a lot of legacy infrastructure. How do you see that working with that? Do you think, it will take a very long time or?
Well, of course, okay, whatever implementation, okay, a city is going to do, okay, should take in consideration, okay, the investment already done, okay, and we should work out on how to capitalize on already done investment, okay, and integrate, okay, to the best level, to the best possible level, okay, those infrastructure, software, and network level. Okay. This is one thing, okay, and that we should take in account. Okay, interoperability should not be the argument, okay, that for the city where, okay, we throw out of the window any investment, all the investment we did in the past, okay, because they were not interoperable, okay, they were not supporting interoperability, or they were not supporting interoperability to the extent that we wish and we would like to have today. There will be a layer of adaptations, okay, layers of integration, okay, to take into the big picture, okay, those investments, legacy infrastructure, as you mentioned, Sarah, and while, okay, evolving over time, okay, the legacy will reduce, okay, and moving, okay, to interoperable solution.
Yeah.
One example is, for example, smart metering. Okay, it has always been considered to be critical infrastructures, okay, and therefore critical infrastructure. One of the mantras is that critical infrastructure should not be on open and interoperable technology. Okay, well, I think we have very high mission critical services in the world that runs on the internet. Okay, and these very high mission critical services, okay, from the financial, healthcare, and safety, they are okay, running on the internet, okay, and they are mission critical, okay, as any other application in the city, okay. So interoperability is not in conflict and incompatible, okay, with mission critical services.
Okay. Related a little bit to that, and just for the audience, we've got time for a couple more questions, so if you have a burning question, please do send it in now. But Gianni, I wanted to follow up with you about, some people might be concerned about openness and how that relates to security, particularly, as you mentioned, mission critical or critical infrastructure. Do you have any insights or examples to share about that?
Well, this is an interesting question, okay, and what is safer, okay, a piece of code that has been reviewed by the community, okay, and or code that have been reviewed by the community for whatever reason, but then of course it's also exposed, okay, to the, let's say, community, okay, with different intentions, okay, then the goodness, okay, or a piece of code that has been developed, okay, by few, okay, and the quality in terms of security, cybersecurity, stability is the function, okay, of the experience and the knowledge of these few. So summarizing together, okay, do we want to bet, okay, on security as a function of a worldwide community versus a function of a small community of developers, okay, that develop a proprietary technology? This is the question, okay, and I think it answers itself.
Okay. And Bruno, do you have anything to add about security? Do you get queries about this in Chile or?
Okay, for us, the future proof and the security as the key element. And today, in IoT network offers very long time of battery duration, but security is not a key. In case of a IoT network based on IP protocols, the security is the same that used in our computer, our smartphone, and it's very similar. Like tell Jenny, infrastructure in space, in public space is critical, and security is a key element. Municipalities today that not consider cybersecurity, but it's changing in the manner to more municipalities adopt enable infrastructure. The security is being seen a new element that need new technical, new human capital to promote and to protect the security of critical infrastructure in the city.
Mm-hmm.
To this point, if I can, Sarah, okay, and
of course, yeah.
As an old computer science guy, okay, if one is seeking security in the digital world, okay, the only way to be secure is just not connect anything, okay, because but then, okay, we should basically probably think to another seminar, okay, what is security in IoT, okay, and how security, okay, is versus, okay, open interoperability. But the point of Bruno is a very good point, okay, we are all willing to connect to open an interoperable system with billions of devices, okay, with gazillions of applications running on this device, okay. Android, okay, is an open source, IP network are there, and we don't ask too many questions about security there, okay. And there are things that we bring in our pockets every day, and we run, okay, mission critical, okay, services for us, from banking, okay, from connecting with our loved ones, and so on and so forth, okay. So we should put security in the right perspective. Assure that security is not an argument, okay, to push back, okay, what are going to be the drivers for the future, which are interoperability, to the sake of the discussion.
Yeah, thank you. So for the final question, I just wanted to ask you both if you could share any examples which you think demonstrate, you know, in a city or an initiative which demonstrate the value of this open and interoperable approach in action. So any outcomes and results that we're seeing so far, or any promising areas?
Yeah, I can start with one if you allow me, Bruno. Okay, one example is the city of San Leandro, Northern California, Bay Area, and they wanted to replace all their street lights luminaires, and were moving from conventional luminaires to LED luminaires, and they realized that, and then doing energy saving with that, and they also realized that, okay, that the street lights, okay, were an infrastructure, okay, a real estate network infrastructure that they would, and they realized that they wanted to capitalize on that. So, and they therefore, okay, they installed, okay, our solution. They ended up with a mesh network, IPv6 LoWPAN, open interoperable, and therefore, okay, they could achieve several additional goals, okay, by doing that. Number one, a network, an IoT network, open interoperable. Number two, okay, additional energy saving and operational efficiency by having connected the luminaires. But number zero, okay, the openness and interoperability, okay, really centered, okay, the goal of livability, sustainability, and the local economy, because a bunch of bachelor students, okay, for local university, okay, they developed what we could not, okay, or we didn't have in our portfolio, okay, they developed the smart waste bin, okay, they developed a device, okay, to be put on the waste bin in the city, and out of that, okay, monitoring the level of waste in the bin, okay, and all this connected to an open interoperable network, okay, and without being dependent, okay, from our any of our knowledge or technology, okay, just using the network that was there. I think this is a bright example of interoperability, and this was already 3 years ago, actually.
Mm-hmm. Excellent, thank you. And Bruno, how about you? Any examples of benefits so far in the cities you're working with in Chile or that you've seen elsewhere?
Okay, in Chile, our recommendation is adopted in 2019. The concept an open smart city is today beginning. Like say in Canada, Bristol, London, it's an open smart city, and we promote the system, like say Gianni, in replace luminance to LED luminance with efficiency in electrical consumption and using the infrastructure of the poles in the city. This is an active, very interesting for the municipalities, and today open operator of mobile solutions look the poles like for 4G in the next years, and it's very interesting that occur today in the world. Open smart city is open source, is open governance, interoperability is key. Without infrastructure, without system coordinates, we don't have better quality of life. We don't have open data to entrepreneurship, to innovation.
Well, thank you. I think that's a good way and a good place to sum up the webinar. So thank you for that, Bruno. And so thank you to the audience who attended today. Just a reminder that you can download the report in the handout section, and we'll also put it in the email which we send out with the webinar recording. So I'd like to thank Paradox Engineering for partnering with us on this webinar, and to thank again our speakers, Gianni, the President and CEO of Paradox Engineering, and Bruno from CORFO. So thank you all again, and thank you for listening in today.
Thank you, Sarah, for your moderation. Okay, and thank you, Bruno. Okay, see you soon.
Okay, thank you, Sarah. Thank you, Jenny. Bye-bye.
Okay, bye-bye. Thank you, everybody. Bye.